Hello everyone, in this video we're going to learn how to work with finite and infinite geometric series. Alright, so we have two theorems right here. The first one is going to be the sum of finite geometric series. It's going to be given by this formula. And the second one is going to be convergence of the geometric series. It's going to be given this formula. Alright, if absolute value of r less than 1, then the series converges to the sum of this guy. If absolute value of r greater than or equal to 1, then the series diverges. Alright. Now, in order to understand how we got these two formulas, please check out the video in the description below or the video 10.2a. Question A. Sigma of 1 over 2 to the n when n goes from 1 to 10. Alright, so if n equals 1, we have 1 half, right? N equals 2, we have 1 half power of 2, right? N equals 3, we have 1 half power of 3 plus etc. until n equals 10, 1 half power of 10, right? Now, in order to get the second terms from the first term, we're going to multiply by 1 half, right? So this one is the geometric series with the common ratio equals 1 half, right? Now question B. If n equals 1, we have 1 divided by 1 is going to be 1. N equals 2, we have 1 half, right? N equals 3, we have 1/3, right? N equals 4, we have 1/4 plus etc. until n equals 20, it's going to be 1 over 20, right? And this guy not the geometric series, right? Now question C. N equals 0, we have 2 times 0 plus 1 is going to be 1. N equals 1, we have 2 times 1 plus 1 is going to be 3. N equals 2, we have 5. N equals 3, we have 7, right? And this one not a geometric series because we don't have the common ratio, right? Now, let's take a look at the example number 2. We need to find sum of finite geometric series. Alright, so we're going to go back over here. The formula right here is going to be the first term times 1 minus common ratio raised to the n over 1 minus r. We're going to populate this one, so it's going to be 4 times 0.3. When k equals 1, it's going to be power of 0, right? K equals 2, it's going to be 4 times 0.3 power of 1 plus 4 times 0.3 power of 2 plus etc. plus 4 times 0.3 power of 11, right? So it tells us that the first term is going to be A1 equals 4, right? The common ratio is going to be 0.3, right? And n equals 12, right? Now the sum of this one is going to be A1 times 1 minus r to the n over 1 minus r, right? So it's going to be 4 times 1 minus 0.3 raised to the 12, right? Over 1 minus 0.3, right? So we're going to print up the calculator. Press calculate. So we have 4 times, hit the fraction right here, 1 minus 0.3 raised to the 12 over 1 minus 0.3, and then press Ctrl Enter. It's going to give you the values of 5.714, right? Now question B looks similar to question A. But in order to apply this formula right here, you need to rewrite this one in the form of this guy right here, k minus 1. Right? So this guy turns out to be sigma k goes from 1 to 12 4 times 0.3. Now 0.3 raised to the k, I can write 0.3 raised to the k minus 1 times 0.3. Right? So I can print 0.3 to the front right here. Right? So now I have a1 equals 4 times 0.3. Right? The common ratio R equals still 0.3, right? And n equals 12, right? So this sum equals a1 is going to be 4 times 0.3 times 1 minus common ratio 0.3 power of 12, right? Divide by 1 minus 0.3, right? So you just take the answer from the left hand side, you multiply by 0.3, right? So I'm going to bring up the calculator, I'm going to multiply this number by 0.3, right? And then I'm going to press Control Enter. It's going to be 1.714, right? Example number 3. Convergent and divergent geometric series. Evaluate each of the following geometric series or state the series diverges. Alright, so we're gonna go back over here, the formula right here. If absolute value of r less than 1, then the series converges, and the sum of the series should be this one, right? If absolute value of r greater than or equal to 1, then the series diverges, right? So we're gonna populate this one. If n equals 0, we have 1, right? N equals 1, we have 1.1. N equals 2, we have 1.1 square, right? Plus etc. Right? So you see that the common ratio is 1.1, which is greater than or equal to 1, right? Then the series diverges, right? Now question B. We're gonna populate this one. So we have S equals n equals 0, we have 1, right? N equals 1, we have 1 over e. N equals 2, we have 1 over e squared. N equals 3, we have 1 over e cubed, right? So then the common ratio is 1 over e, right? And you know that e is going to be 2.718, right? So this guy less than 1, greater than 0, right? Then the series convergent, right? Then the sum should be S equals A over 1 minus R, right? Now A, which means the first term, right? So it could be 1 right here. Over 1 minus 1 over E, right? So it could be E over E minus 1. Now let's take a look at the question C. We need to populate this one, right? So n equals 1, we have 3 times negative 0.75 to the first plus n equals 2, you have 3 times negative 0.75 square, right? Plus 3 times negative 0.75 cube plus etc. Right? And observe that the common ratio is negative 0.75, right? Which is greater than -1 less than 1, right? So I convert this one to improper fraction. It's going to be -3, 4, right? So then the sum is going to be, the first term is going to be right here, right? So I have 3 times -3 over 4 over 1 minus common ratio. Common ratio is -3 over 4. So it could be plus 3 over 4, right? So we're going to simplify this one. It's going to be -9 over 4, right? Divide by, simplify this one. It's going to be 7 over 4, right? Now let's multiply the top and bottom by 4. So the final answer must be -9 over 7, right? Now question D. Let's populate this one. So if n equals 0, we have 3, right? N equals 1, we have 3.5, right? N equals 2, you have 3 over 2 square. N equals 3, you have 3 over 2 cube, etc. Right? Now you're going to factor 3 out, so it could be 3 times 1 plus 1 over 2 power of 1 plus 1 over 2 square plus 1 over 2 cube. And observe that the common ratio is 1/2, which is greater than 0, less than 1, right? And the first term is 3, right? So you have the sum is going to be A1, which means 3 over 1 minus 1/2, right? So it's going to be 6, right? Now question E. N equals 0, we have 3 over 2 power of 0 plus 3 over 2 power of 1 plus 3 over 2 square plus etc. Right? So the common ratio is 3.5, which is greater than 1, right? Then the series diverges, right? Now question F, let's populate this one. N equals 0, you have e over pi power of 0 plus e over pi power of 1 plus e over pi square plus etc. Right? So the common ratio is e over pi. You know that e is going to be about 2.718. Pi is going to be 3.14 something, right? So this guy less than 1 but greater than 0, right? Then the series convergent, right? So the sum is going to be the first term is right here. It's going to be 1, right? Over 1 minus e over pi, right? So if you simplify this one, it turns out to be pi over pi minus e, right? Now let's move on to question G. First, we need to split this sum into two sums, right? So we have, so it's going to be sigma when n goes from 0 to infinity of 2 over 5 altogether to the n minus 1. Subtract. Now, this one right here, you have the power of n minus 1. This one is n plus 1, so which is 2 units greater than this one, right? I need to rewrite this one and this one in the same power, n minus 1, right? So, the top right here, I can rewrite this one as 3 square times 3 to the n minus 1, right? So, 3 square is going to be 9, right? And then this guy and this guy can be combined as 3 over 5 to the n minus 1, right? Now I'm going to separate these two guys. So I have, now I need to calculate each of this one, right? So I'm going to start with this guy first. Now I'm going to separate this guy as 2 over 5 to the n times 2 over 5 to the -1, right? So I put 2 over 5 to the -1 to the front, and I'm gonna end up with this guy right here. Now look at this series right here. The common ratio is 2 over 5, which is greater than 0, less than 1. So then the series convergent, right? Now I have 2 over 5 raised to the negative 1. It's going to be 5 over 2 times. When n equals 0, you have the first term actually 1, right? 1 minus common ratio, which means 2 over 5, right? If you simplify this one, the answer should be 25 over 6, right? Now the second one, you do exactly the same thing, right? So basically, you have 9 times 3 over 5 to the negative 1 sigma when n goes from 0 to infinity of 3 over 5 to the n, right? So the sum is going to be 9 times 3 over 5 to the negative 1 is going to be 5 over 3, right? Times 1, right? The first term is 1, and 1 minus common ratio is going to be 3 over 5. Because 3 over 5 less than 1 greater than 0. So then this series is convergent, right? Now if you simplify this one, it's actually 75 over 2, right? Now I'm going to combine these two guys, 25 over 6 and 75 over 2, right? So you have 25 over 6 subtract 75 over 2. The answer must be negative 100 over 3, right? Now let's take a look at this question. We need to populate this one, right? So it's going to be 4 plus 4 times 0.6 plus 4 times 0.6 square plus 4 times 0.6 cube plus etc. Right? Now the common ratio is 0.6, right? And the first term is 4, so it's going to be the sum equals 4 divided by 1 minus 0.6, right? So it's going to be 4 divided by 0.4, right? So it's going to be 10, right? Now the last one right here. The first term is 3, the common ratio is 0.1, right? So then you have the sum is going to be 3 divided by 1 minus 0.1, right? So 3 divided by 0.9, right? Multiply the top bottom by 10, so you have 30 divided by 9, right? And then divide the top and bottom by 3, so you have 10 over 3. This one is the final answer, right? Now let's take a look at the example number 4. Decimal expansion as a geometric series. Write 1.0.25 as a geometric series and express its values as a fraction. Alright, so you see that there is a part right here. It means 25 repeating, right? So 1.025 equals 1.025, 25, 25, 25, keep repeating, right? Etc. And then it's gonna be 1 plus, now I'm gonna cut this one off 3 decimal number, right? So I'm gonna end up with 0.025, right? Next it's gonna be plus 0.00025, right? Next plus 0.0000025, right? Plus etc. right? So it's gonna be 1 plus 25 over 10 cube plus 25 over 10 power 5 plus 25 over 10 power 7, right? Plus etc. Now I'm going to divide the top and bottom by 10. So I'm going to end up with 1 plus 2.5 times 1 over 10 squared plus 2.5 times 1 over 10 to the 4 plus 2.5 times 1 over 10 to the 6 plus etc. Right? And then this one equals 1. Now look at this guy right here. Actually, it's going to be geometric series, right? So it's going to be plus sum when n goes from 1 to infinity of 2.5 times 1 over 100 to the n, right? Now we're going to populate this one. So then you have 2.5 times n equals 1, you have 0.01, right? Plus 2.5 times 0.0001, right? Plus etc. Right? So you see that the common ratio is 0.01, right? And the first terms a1 equals 0.025, right? If you multiply this one, it's actually 0.025, right? So then the sum equals, don't forget this one, 1 plus the first term 0.025 over the common ratio. It's going to be 0.01, right? So 1 subtract 0.01 because this one less than 1 greater than 0, right? So we have the sum. Now if we simplify this one, it's going to be 1 plus, I'm going to multiply the top and bottom by 1000, right? So I have 25 over 1000 minus 10, right? So then it's going to be 1 plus 25 over 990, right? So it's going to be 1015 over 990, right? Now divide the top and bottom by 5. You're going to end up with 203 over 198. Now let's move on to the next one, telescoping series. Telescoping series can have the form b1 minus b2 plus b2 minus b3, etc. So you see that all terms inside cancel out, right? You're gonna have the first and the last term only, right? Now a telescoping series converges if and only if b sub n approaches a finite number as n approaches infinity, right? So you're gonna take the limit of the final terms right here, right? Now let's look at example number 5, telescoping series. Find the sum of the following series. Alright, so first we need to populate this one, right? If n equals 1, we have 1 over 2 minus 1 over 2 squared, right? Plus n equals 2, you have 1 over 2 squared minus 1 over 2 cubed, right? Plus 1 over 2 cubed minus 1 over 2 to the 4, right? Plus etc. Plus 1 over 2 to the n minus 1 over 2 to the n plus 1, right? And this guy cancel out, this guy cancel out, this guy cancel out, this guy and the terms before it cancel out, right? So you're gonna end up with the first term 1/2 and the last term right here, you're gonna take limit of this one, right? When n approaches infinity, right? When n approaches infinity, this guy approaches 0, right? So the answer must be 1/2. Now let's take a look at question B. In order to do question B, we need to do partial fraction decomposition. We learn in unit 6, right? So I have 1 over n times n plus 1 equals a over n plus b over n plus 1, right? So then this guy becomes a times n plus 1 plus b times n over n times n plus 1, right? Now I'm going to equate this guy and this guy right here, right? Because denominator are the same, right? So I have a times n plus 1 plus b times n equals 1. I'm gonna let n equals -1, right? And then this guy gone, right? So you have b times -1 is going to be negative, b equals 1, then b equals -1, right? I'm gonna let n equals 0, so this guy gone, right? So I have a equals 1, right? So then this guy becomes 1 over n minus 1 over n plus 1, right? So I put the sigma in the front when n goes from 1 to infinity of the whole thing right here, right? Now I'm going to populate this one. So if n equals 1, we have 1 over 1 minus 1 over 2. N equals 2, we have 1 over 2 minus 1 over 3, right? Plus, etc. Plus until the last one, 1 over n minus 1 over n plus 1, right? This guy cancel out. This guy and this guy cancel out. This guy and the previous term cancel out. So we're going to end up with 1 minus 1 over n plus 1, right? So then the sum of this one equals 1 minus limit of this one when n approaches infinity, right? So then it's going to be 1 minus 0 is going to be 1. Now, example number 6 is slightly different from what we did before. Many telescoping series contain several terms B1, B2, B3 that do not cancel and become part of the sum. Now, we need to do partial fraction decomposition first, right? So, I'm going to have 2 over, I'm going to factor the bottom out first. So, it could be n plus 3 times n plus 1, right? Equals a over n plus 3 plus b over n plus 1, right? And then this guy becomes a times n plus 1 plus b times n plus 3 over n plus 3 times n plus 1, right? Now I just equate this guy and this guy, right? So I'm going to end up with a times n plus 1 plus b times n plus 3 equals 2. I'm going to let n equals -1, right? And then substitute -1 for n over here. I have 2b equals 2 and then b equals 1. I'm going to let n equals -3, right? So this guy equals 0, right? So I have -2a equals 2 and then a equals -1, right? So this sum right here becomes the sum when n goes from 1 to infinity of -1 over n plus 3. So I put this one in the back, right? And 1 over n plus 1, I put this one in the front, right? Since this series is slightly different from what we did in the example number 5, I'm going to populate this one in different way to help you understand better. Alright, so I'm going to deal with the positive term first. N equals 1, you have 1/2. N equals 2, you have 1/3. N equals 3, you have 1/4. N equals 4, you have 1/5, right? Until the last term, it's going to be 1 over n plus 1, right? Now the negative terms, n equals 1, you have negative 1/4, right? So I put negative 1/4 here. N equals 2, I have negative 1/5, right? Etc. until the last term, 1 over n plus 3. So it could be right here. Right? Now, the one before 1 over n plus 3 is 1 over n plus 2. Right? And the one before this term is going to be 1 over n plus 1. Right? Now, we're going to add this guy up. Right? So does that mean this guy cancel out? You're going to end up with the first two terms and the last two terms right here, right? So the sum equals 1/2 plus 1/3 minus limit of 1 over n plus 2 plus 1 over n plus 3 when n approaches infinity, right? So when n approaches infinity, this guy approaches 0, this guy approaches 0, right? You're going to end up with 1 over 2 plus 1 over 3, and it's going to be 5 over 6. This one is the final answer, and it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.